Hello and welcome to another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 1, Lesson 7 on using your calculator to explore expressions and equations. Now I'm going to be using the II.Inspire to do what I'm going to work with today. Almost all graphing calculators, I would actually say all graphing calculators, have the capabilities to do what I'm going to go through today. Unfortunately, all graphing calculators, even other Texas Instruments calculators, do things in slightly different ways. And that really is unfortunate because I can't go through what the TI-83 and the TI-84 and the TI-Inspire and the Casio and the Hewlett-Packard. I can't do a video on each one of them. Well, maybe I could, but I'm not going to. So what we're going to be doing today is going through these capabilities, and if you don't have a TI-Inspire, I would highly suggest you still try to figure out how what I'm going to show you is done on these calculators because it's extremely helpful for moving forward. Anyhow, let's get into it right now. So, evaluating expressions. The first day in Algebra 2, we started off by looking at expressions and then evaluating what those expressions were, well, what their value was when we put in particular values of the input variable. The graphing calculators that are now used in high school math courses are extremely powerful, and they can help us to easily evaluate algebraic expressions and check to see if a particular values are solutions to equations. So right away, let's see how easy it is to have a calculator come up with the value of an expression in exercise 1, letter A. Find the value of each of the following expressions by using the store feature on your calculator. Letter A, x squared minus 2x plus 7 for x equals 5. Now, of course, we could actually, in our calculator, type in parentheses 5, parentheses squared minus 2 times 5 plus 7 and get a value. No question about it. But what I want to do is actually show you how you can store a value of 5 into x and then just type out this expression and have it tell you what the value is. Now I'm going to kind of bail out on here because I want you to be able to see the calculator in its nice large form, okay, or as large as it's going to possibly get. Now on the TI-Inspire, there's a little button here that says VAR for variable. But above that is a little blue thing that says STO for store. So what I'm going to do is I'm going to type in 5 and then I'm going to hit the store button, which just gives me this little arrow, and then I'm going to type in x, and I'm going to hit enter. Now, right now, the calculator thinks x has a value of 5. So if I were to type in 2x and hit enter, the calculator says 10. Or if I was to type in x plus 20, the calculator says 25, because x is equal to 5. Now, of course, what I actually want to know is what the value of x squared minus 2x plus 7 is. And that has a value of 22, right? How nice is that? I just tell the calculator, oh, x is equal to 5, or take 5 and store it in x. I type this expression in, and boom, I know what the value is. And the value is 22. All right, and my calculator mysteriously disappears. All right, so it's really, really just beautiful. Now, some students get very worried because they think, oh, well, what happens if I graph later on? Will the calculator think x is equal to 5? And the answer is no. All right, so storing a value into x at this point doesn't affect anything else except for when you are on a calculator screen, like the actual calculation screen, and you ask it to do something with x. Let's take a look at another one. All right, so let's take a look at what we get when we try to do this rational expression. So I'm going to take negative 10 and I'm going to store it into x. All right, now the calculator thinks x is equal to negative 10. I am going to now put in my fraction bar and I'm going to type in 2x plus 6 in the numerator, and I'm going to type in 3x minus 5 in the denominator, and I'm going to hit enter, and my calculator tells me 2/5. All right. If I needed it to express it as a decimal, I'd have to hit the Control Enter button, which is the approximately equal to button, which is weird because it's not approximately equal to 0.4. It's equal to 0.4, but it will always, the II.Inspire will always give you the fraction version, at least initially. So my answer is 2/5. All right. So let's see, especially for those of you who are kind of following along, let's see what you can do in letter C. We've got the absolute value of the quantity 7x minus 20 plus x squared for x equals 2. All right, why don't you go ahead and use the store feature and then type that expression in to see what it gives you. All right, well, what I'm going to do really quickly is I just want to kind of clear out the board just so that it's a little bit cleaner. I'm going to take 2, store that in x. Excellent. I'm going to go up here, grab my absolute value. That's going to be 7x minus 20. I got to get outside of the absolute value bars. Now I'm going to hit plus x squared, enter, and all of that is equal to 10. I love the store feature on the graphing calculator. Absolutely love it, right? Because if there are algebraic expressions that I want an isolated value for, but I don't want to risk having to kind of like type the crazy expression in with the number substituted in, it is so much easier to store the value in x and then type the expression out, right? And have the calculator give me its value. All right, let's keep playing around. I'm going to go back into my full screen mode and let's kind of move on. Let's take a look at exercise number 2. Consider the expression the square root of 6 minus 2x. What happens when you try to use store to evaluate this expression for x equals 5? Evaluate the expression by hand to help explain what the calculator is trying to tell us. All right, in other words, what I'd like you to do is use the store feature to try to evaluate this particular expression when x is equal to 5. It's going to give you something funky, but I want you to see that for yourself. And then once you do see that, then I'd like you to try to evaluate it by hand to see if you can figure out what the calculator is trying to tell you. Pause the video now. All right, well, let's take a look. I'm going to exit out of this, bring back my graphing calculator. All right, what do I want? I want 5 stored in x. And notice I always have to put the number first. I never want to try to store x into 5. That doesn't make any sense. I can't do that. 5 is 5. All right, so now what I want is I'm going to type out the expression square root of 6 minus 2x. And oh, all right, let's talk about this a little bit. All right, so it says error, non-real calculation, and I won't go through all of this verbiage, all right? Later on in this course, we're going to actually see how to evaluate the square root of a negative number. But in order to do that, we're going to have to introduce what are called imaginary numbers. That's right, there's going to be numbers that we actually call imaginary, all right? And they're not actually imaginary, but that's what we call them, all right, as opposed to a real number. Not the point. The point is, your calculator is saying, whoa, 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 I can't do this. This is weird, all right? And all I want you to really realize is that it's giving you an error right now. All right, so it says, you know, error, and answer is non-real. All right, now let's take a look at why that is. So let's actually do the evaluation, right? I'm going to have the square root of 6 minus 2 times 5. All right, so that's going to be the square root of 6 minus 10. And that is going to be the square root of negative 4. All right. Now we talked about already in this course the fact that you cannot, with real numbers, take the square root of a negative number. It's not 2, right, because 2 times 2 is 4. It's not negative 2, because negative 2 times negative 2 is positive 4. So this can't be done with real numbers at this point. All right. Again, later on, we're going to see how to, and by later on, I mean like months from now, we're going to see how to actually evaluate the square root of a negative number. And we can even have our calculators evaluate the square root of a negative number as long as we put it in imaginary number mode or complex number mode. But we'll get to that later on. Let's keep going. All right, exercise number 3. Consider the expression 3x plus 2 times x plus 5. Answer the following questions. Letter A. Express that product as an equivalent trinomial written in standard form. Great. So why don't you go ahead and take the product, all right, and multiply it all out like we did a few lessons ago when we were multiplying polynomials, and just get that answer here. Take a minute to do that. All right, let's do it. So simple enough, I'm going to just do a little, well, actually, maybe I'll write it down here again so it's a little bit bigger. 3x plus 2 times x plus 5. I'm going to do just a little bit of foiling. First gives me 3x squared, outer plus 15x, inner plus 2x, and last plus 10. It's going to give me 3x squared plus 17x plus 10. All right, just a little bit of multiplying binomial work, simple enough. All right, now, letter B. Evaluate both the trinomial and the original product for x equals negative 2. What do you notice? And again, I want to be doing this with the store command right now. I don't want to be doing it by hand. That's not really the point. So let's just take a look. Let's kind of bail out of this real quickly. Let's open up our calculator again and maybe clear all of this out, just so that we have a nice open thing. Now, what am I doing? I'm evaluating these for x equals negative 2. So I'm going to put negative 2 in for x. I'm going to try in for x. And what I want to do is I want to evaluate first the expression looking like this for x equals negative 2. And then, and I don't have to restore x equals negative 2, I want to also evaluate this trinomial. All right? So first things first, let's put in parentheses 3x plus 2 times x plus 5. All right, and that gives me negative 12. So 3x plus 2 times x plus 5 when x equals negative 2 is equal to negative 12. And now let's do the same thing. Let's actually type in 3x squared plus 17x plus 10. And that also gives me negative 12. 3x squared plus 17x plus 10 when x equals negative 2 is also equal to negative 12. Now, the whole sort of purpose of letter B is to remind ourselves that when we do an algebraic manipulation like this, and we get this trinomial instead of this product, right, then what we're still getting are two equivalent expressions, right? This expression and this expression are equivalent to each other, which is why when I evaluate both of them using the store command and x equals negative 2, I'm getting the same value out at the end. All right, just a reminder of that. Anyway, let's keep the calculator or keep the screen kind of looking like this, and let's take a look at letter C. Use the store command to evaluate the trinomial from A for x equals negative 5. Why does this value of the trinomial turn out to be this specific value at x equals negative 5? Explain. So I've got my product here, but what I really want us to do is just evaluate this trinomial when x equals negative 5 using the store command. So why don't you go ahead and do that now? All right, awesome. Let's do it. So we've got to store a new value in x. All right, I'm going to do negative 5 stored in x, enter. All right, and I can actually scroll all the way up if I don't really want to retype out the expression. I can grab the expression again, hit enter, and I get a value of 0. Right? So my trinomial has a 0 when x is equal to negative 5. So this is equal to 0 at x equals negative 5. There we go, right? So I've got a 0 at x equals negative 5. Now, why does the value of the trinomial turn out to be the specific value at x equals negative 5? That's easy enough. And that's because it has a factor of x plus 5, right? Throughout this course, we are going to, one of the big pictures in Algebra 2 is going to be to truly understand the link between the zeros of an expression and the factors of an expression. So because negative 5 makes this factor equal to 0, it's going to make the entire expression equal to 0 when x is equal to negative 5. We would also have another 0 for this particular factor, but that 0 would equal negative 2/3, and that one's a little bit uglier, although with the store command, still perfectly easy to actually evaluate it. All right, let's keep moving. Now, let's talk about how we can use the calculator to check solutions to an equation. Your graphing calculator can literally tell you whether a particular value is a solution to an equation. Recall, though, that a solution to an equation is any value of the substitution variable that makes the equation true. We talked about this a lot in the last lesson when we reviewed how to solve linear equations. Okay? So let's see how we can have the calculator tell us whether or not a particular value is a solution to an equation. Let's go with exercise number 4. Consider the equation 3x plus 2 equals negative 10. Letter A, solve the equation using standard techniques. All right, this one should be a piece of cake. Many of you, I hope pretty much all of you, could probably solve it in your head, but go ahead and take about 20 seconds to solve this equation. I mean, you definitely want to be careful solving it. We can all make mistakes when we solve equations, but let's take a brief amount of time to solve this two-step equation. I'm going to subtract 2 from both sides. I'll get 3x is equal to negative 12. I'll divide by 3 on both sides, and I'll get x equals negative 4. All right, now let's take a look at letter B. Store the value you found in A in the variable x, and then type the equation into your calculator. What does your calculator tell you? All right, awesome. Let's take a look at this. I love this feature of graphing calculators. So let's bring our calculator out. All right, I'm going to go back and clear this thing out. Let's do it. I'm going to take negative 4 and I'm going to store it in for x. Now I'm going to actually type the equation in. 3x plus 2, the equals sign is right below the control sign on the II.Inspire. So let's talk about that for a minute, right? So there's an equals sign actually on the II.Inspire right below the control button. So the control button there is in blue, the equals sign is right there. So literally here I just type out 3x plus 2 equals negative 10. And remember, right now the calculator thinks that x is equal to negative 4. When I hit enter, the calculator says true. Right? And that is exactly what the solution to an equation is. It's something that makes the equation true. And just for a counterpoint, right? Let's say I did something like this. Let's say I made a mistake and I thought that the answer was x equals 6. Or sorry, x equals negative 6, and now it's angry at me. There we go. So let's say I had that and I typed in the exact same equation, 3x plus 2 equals negative 10. And I hit enter. It says false, right? And it says false because negative 6 doesn't make the left-hand side equal to the right-hand side. So it's not a solution. I mean, how wonderful is this, right? Every time you've ever been in an algebra class where they say, solve the solution and check, this is your check. Right? And you don't have to do the arithmetic on both sides of the equation to make sure that negative 4 is equal to negative 4 or negative 10 is equal to negative 10 or whatever it would be, right? All you have to do is store the value into x that you got, type the equation in, and by the way, it would also work with inequalities as well if you wanted to see if something was a solution to an inequality. And if it says true, well, you're good to go. And if it says false, you're not. Now there is one little caveat to this, all right? If the answers are irrational, Okay? Sometimes the calculator will tell you that you do not have a solution to the equation, but it'll give you a little warning. It'll say, hey, this was done with approximate methods, so we may not be right here. And I know that sounds a little bit crazy, but when you're working with irrational numbers where the decimal representations go on forever, the calculator can have a little bit of a hard time comparing the left side of an equation to the right side of an equation. But when the answers are sort of nice rational numbers, like, -4 or like 3/2 or something like that, it's got no issues figuring out whether you've got the right answer. All right, I love, love, love the ability that calculators have to check an answer. All right, so by the way, it tells you it's true. True means you've got a solution. So let's take a look at exercise number 5. Solve the equation n plus 5 over n minus 1 is equal to 7/3. Check your solution using the store command. All right, well, why don't you go ahead and solve this equation, do it by cross multiplying, okay, that's typically how you solve an equation where you have a fraction equal to a fraction. Once you have your solution, and spoiler alert, it's going to be fractional, your actual answer, what I'd like you to then do is check to see if it's true by using the store command. Pause the video now, go through all of that, and then we'll take a look. All right, let's do it. Well, solving this by cross multiplication, right, we're going to multiply this and this, will give me 7 times n minus 1 is equal to 3 times n minus 5. Doing a little distribution, we'll get 7n minus 7 is equal to 3n plus 15. You get a little bit there. Subtract a 3n from both sides. 4n minus 7 is equal to 15. Add a 7 to both sides, we'll get 4n is equal to 22. Move that out of the way, scroll down a little bit, divide both sides by 4, and we'll get n is equal to 22/4, which, if you want, will reduce down to 11/2. So I think we'll just stick with that. N equals 11/2. So let's now show what this looks like. I'm going to maybe put my solution up here so it'll be easier to see. Let's take a look on our calculator. And now I can't see it at all. Actually, we'll just remember that it's 11/2. We'll put it right there. All right, let me clear this out. Let's do it. I can even use the fraction bar. I can even use n. I don't even have to use x in this situation. So why not? I'm going to store 11/2 in n. Great. Move my little pen icon. Let's now type our equation in. Our equation is, I have to do it in terms of the variable that I'm using here, especially if I store it that way. N plus 5 divided by n minus 1 is equal to 7/3 and true. True! Yay! Which tells me I got the right answer, right? And again, you could see in a variety of situations where you might botch something here, maybe you distribute incorrectly, maybe you end up having 7n minus 1 equals 3n plus 5, you go through it, you solve it, get some ugly fractional answer, you're like, well, that might be right, it might be wrong. All you have to do is be willing to spend another 15 to 30 seconds to type this in to see if you've got the right answer. All right, let's keep going. Now, so far, right, we've used the store command, and the store feature is extremely helpful when you're trying to determine the value of an expression at 1 or 2 input values of x, or you're trying to like check the solution or solutions to an equation. But if you want to know an expression's value for multiple inputs, then typically tables on your calculator are a much, much better tool. Now, I'll be honest, I am not in love with the way the II.Inspire does calculator tables. I much, much preferred them on the TI-83 Plus and the TI-84 Plus. But I got the calculator I got, and that's the one that I'm using. The II.Inspire, I think, is the most popular calculator for classroom instructional use, which is why we use it, and it's a great calculator overall. But let's take a look at exercise number 6. The expression x cubed plus 2x squared minus 16x minus 32 has an integer 0 somewhere on the interval 0 is less than or equal to x, which is less than or equal to 10. Use a table to find the 0 on this interval. Show a relevant portion of the table. Now remember, a 0 is simply a value of x that will give you an expression that's equal to 0. An integer 0 is a 0 that isn't fractional, it isn't irrational, right? It's a whole number, but it could be negative. Now, here it says it's an integer 0 somewhere on the interval 0 to 10. Now, what I could definitely do is I could store 0 in x, type this in, see if it's equal to 0. Store 1 in x, type this in, see if it's equal to 0. And again, that wouldn't be that slow, but it would take some time. So what we're going to do is we're going to bring our calculator out. All right, and for this, what we want is we actually want to use a graph. So no, that's not what I want. I'm going to go over to my graph grid, okay? And what I'm going to do is I'm going to type in that expression as if I was going to graph it, all right? So I'm going to do x to the third, and we're going to do a lot of graphing on our graphing calculators in this course. Not so much today, but I've got my function, all right? I've typed it all in. Okay, I'm going to hit enter, and yeah, it graphs it. Awesome, whatever, right? And maybe even by looking at the graph, you can figure out what the 0 is. But I want to talk more sort of extensively about tables rather than just zeros. Now, one way to get the table is by hitting the menu command and simply going down to option 7, which is table. A quicker way of doing it is hitting the control button and the letter T, and then that pops us into a table. Now again, what I don't particularly love is how sort of cramped the table gets, and we're going to see this even more in another example where we're going to want to look at a table for 2 functions. But right now, what I've been told is that I've got a 0. Sometimes it just scrolls like that very quickly, somewhere between x equals 0 and x equals 10. So I can look, when x is equal to 0, my expression has a value of negative 32. When x is equal to 1, my expression has a value of negative 45. When x is equal to 2, my expression has a value of negative 48, etc. I feel like I need to touch very slowly. There it is. Right? When x is equal to 4, right, my function has a value of 0. Okay, and there is my 0. Now it did say show a relevant table. So here's sort of a table that I could use to justify it. Here are those values that we were talking about at the beginning. But here is that 0. And again, that is very important. Zeros are going to become huge in Algebra 2. So we'd want to be able to see, especially if our zeros are sort of easy ones, right? Whole numbers or integers, right? It's very easy then on a table to see that 0. And again, tables are really kind of the store function on steroids, right? So instead of having to store each one of these individual values of x and then ask our calculator what this expression is equal to, we just put the expression in once and we can then generate those values. Let's keep going. All right, last problem. Now, let's consider a more complicated expression. Let's take a look at exercise number 7. Consider the more complex algebraic expression shown below, x plus 5 times x plus 8 minus x plus 3 times x minus 2. This relatively complex expression simplifies into a linear binomial expression. Determine this expression carefully. Show your work below. All right. I'd like you to actually play around with this a little bit on your own. Now, I mean, what's really dicey is when you end up subtracting this product. I think you can find both products pretty easily, but then when you subtract this one from this one, it might get a little bit trickier. So I'd like you to take your time. I would suggest multiplying these two out kind of separately, and then doing that subtraction. Pause the video and probably take up to a couple minutes to do that algebraic manipulation. All right, first let's figure out what x plus 5 times x plus 8 is. That's going to be x squared plus 8x plus 5x plus 40. So that's going to be x squared plus 13x plus 40. And then let's do x plus 3 times x minus 2. That's going to be x squared minus 2x plus 3x minus 6. That's going to be x squared plus x minus 6. All right, wonderful. All right, so now really what we have is we've got x squared plus 13x plus 40 minus x squared plus x minus 6. All right, making sure that all looks good. These parentheses really aren't doing anything at all, but this one reminds me that I have to distribute that subtraction. All right, x squared cancels negative x squared. 13x minus x gives me 12x, and 40 plus 6 gives me 46. All right, looks good. Now, of course, there's a lot of places that this could have gone wrong, right? We could have made a mistake in some of our foiling. Probably the biggest place that it would go wrong is when we subtract off this trinomial from this one. Oftentimes people will forget to distribute the negative, in which case instead of having a 46 here, you could have easily had a 34, let's say. All right. Now, what does this have to do with tables and store and all of that? Well, one of the beautiful things about, right, the table command especially, is that I can now really use it to check to see if these two are equivalent expressions, i.e., did I do all of my algebra right to go from here to here? And I almost kind of wish I had made a mistake. Maybe I did. Let's see. So let's bring this thing up. Let's bail on this really quick. Bring this out. And actually, I'm going to bring this back up, in which case I just lose my calculator again. All right, so what I'm going to do now is I'm going to actually just go in, do a brand new document. New document, no, I'm going to add a graph. All right, so what I'm going to do is for my first function, I'm going to put in that really complicated expression that we started with. X plus 5 times x plus 8 minus x plus 3 times x minus 2. All right, complicated expression in F1, my first function. I hit the down arrow. That brings up F2. This one, I'm going to put in my simpler expression. All right, now, to begin with, the fact that it drew one graph immediately over the other graph, to me, pretty much tells me that they're exactly the same. But let's actually now take a look at a table here. So if I go into my table and I hit Control-T, right, one of the things that's a little bit unfortunate is that at least in this view, you can really only see your x values and the first column for your y values. Now, if I hit the right arrow, I can then, whoops, I hate it when it does that, escape, whoop, right? If I hit the right arrow, it will then show me the values for my second function. One of the things I love about the TI-83 Plus and the 84 Plus is that you could see if I had 3 or 4 functions in here, it would show me almost a spreadsheet-like view, which we can get on this calculator, but it's a lot more difficult to do so. It would show me kind of like a spreadsheet-like view where I could really compare the values of the two functions. All right, we can get that on this, but we have to kind of futz around a little bit with the calculator screen. So let me just show you how to do that right now. All right, it's a little bit tricky, and especially when you have a handheld, because what you're looking to do is you're looking to kind of shrink down that piece and then open this piece up a little bit more. Now, when you do that, though, you get a great view. All right, so what we can now see is that when x is equal to 1, right, the two y values are the same, 58 and 58. When x is equal to 2, the two y values are the same, 70 and 70, 82 and 82. And look, the point here is not what these values are. The point is, whatever I'm getting for this really complicated expression is exactly the same as what I got for the very simple expression, which means that the two expressions are equivalent. All right, that is the whole point and what we're trying to get at here. Let me minimize this, go back here, and again, the idea is if we wanted to fill out our calculator screen, there they are. We would get exactly the same values in that table for both the complicated expression that we put in F1 and for the less complicated expression that we put in F2, and that what that is showing us is that we did our simplification correctly. If we had made a small mistake, like perhaps subtracting the 6 instead of adding the 6 at this point, giving us 12x, let's say, plus 34, then what would end up happening in that situation is that these values wouldn't be the same, and it would tell us that this expression is not equivalent to that one, and therefore we had made a mistake in our algebra. Now, we might not know where the mistake was, but we'd know that there was a mistake. Okay, let's wrap this up. So today we looked at a lot of different things on the graphing calculator. Really, the most important of which was the store feature, the ability to literally take a number, store it in X or whatever variable you want to use, type the expression out, and figure out what its value is. Not only that, but we can not only just type out an expression, we can type out an equation, right? And we can see whether or not the value that we stored for X, let's say, is a solution to that equation. If the calculator says true when we type in the equation, then what we found was a solution. And if it says false, it isn't. Now, we also looked at tables, which are a great way to see multiple values of an expression, right, all at once without having to use the store button. And that can be used in a variety of situations. You've probably used tables on your calculator quite a bit at this point, but you probably haven't used the store function quite as much. So I would suggest making sure, regardless of what kind of calculator you have, that you learn how to use these features because they are extremely helpful. All right, for now I just want to thank you for joining me for another Algebra 2 lesson for eMath instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.